Ever wondered why your bends are not accurate? It might be because you're overlooking some key elements. In the world of metalworking, precision is the name of the game, and when it comes to bending metal, understanding the main bending parameters is crucial. These parameters can be the difference between a perfect bend and a botched job. There are three primary parameters to consider: the thickness of the material, the bend radius, and the bend angle. Each plays a significant role in the bending process. The thickness of the material determines how much force is needed for the bend. The bend radius affects the degree of deformation, while the bend angle controls the final shape of the bend. Neglecting these parameters can lead to inaccuracies, resulting in time and material waste. So if you want to step up your bending game, start by mastering these parameters. Mastering these parameters can significantly improve the accuracy of your bends. First up, let's tackle the thickness of the material. It's a critical aspect of bending that can greatly impact the outcome of your work. Imagine you're bending a matchstick and a log of the same length. The matchstick, being thinner, would easily snap, while the log, due to its thickness, would require a lot more force to bend. That's a basic illustration of how thickness influences bending, but it's not just about the thickness alone. Different materials, even with the same thickness, have different bending characteristics. Steel, for instance, has a higher tensile strength than aluminum, which means it requires more force to bend. These variations in the properties of materials play a significant role in determining the bending process. A comprehensive understanding of your material's thickness can help you achieve more accurate bends. It's like knowing your ingredients well before you start cooking. So, get to know your material, its thickness, and its characteristics, and you'll be on your way to perfect bending. Next, we move on to the bend radius. This term might sound complex, but it's actually quite straightforward. The bend radius is determined by the interplay between the thickness of the material you're bending and the size of the tool you're using to bend it. Imagine trying to bend a sheet of paper around a pencil versus bending it around an eraser. The pencil will give you a smaller bend radius, and the eraser will give you a larger one. Now you might be thinking, the smaller the better, right? Well, not always. A smaller bend radius can lead to more deformation in your material, which is not always desirable. It's like trying to fold a piece of paper in half without creasing it. Sounds impossible, right? That's why knowing your bend radius is crucial. It helps you avoid unwanted deformation and increase the accuracy of your bend. So remember, a well-calculated bend radius is your friend in the world of metal bending. Finally, we have the bend angle. This is the angle formed by the bent material, a crucial factor in the bending process. Picture it this way: you have a flat sheet of metal and you decide to bend it. The angle at which you've bent it is what we call the bend angle, but how do we measure it? Well, it's done from the unbent flat surface to the newly formed bend. The bend angle can be anything from 0 to 180 degrees, depending on your desired outcome. And why is it important? The bend angle directly affects the final product's dimensions. A slight variation in the angle can lead to a significant difference in the final product's size and shape. So, in order to achieve precision in your bends, the bend angle must be measured accurately and consistently. The bend angle, when measured correctly, can greatly enhance the precision of your bends. Now that we've covered the basic parameters, let's dive into the neutral axis and the K factor. In the realm of bending, the neutral axis is your invisible ally. It's an imaginary line running through the thickness of the material being bent. Where no stretching or compression occurs during the bending process, its location is crucial as it directly impacts the bend's outcome. But how do we find the neutral axis? That's where the K factor comes into play. The K factor is a value that represents the location of the neutral axis within the material thickness. It's a ratio essentially telling us how far from the inside surface of the metal the neutral axis lies. You might be thinking, well, that's a lot of math for a simple bend. True, but knowing these details can be the difference between a perfect bend and a costly mistake. Understanding the neutral axis and the K factor can take your bending skills to the next level. So why is the K factor so important? Well, let's take a moment to dive into the nitty-gritty of this fascinating element. The K factor is essentially a ratio that represents the location of the neutral axis with respect to the thickness of the sheet metal being bent. It's a crucial factor because it helps predict the amount of stretching and compression that will occur during the bending process. Imagine you're folding a piece of paper. When you make that fold, one side of the paper stretches while the other side compresses. The same principle applies to bending metal. The K factor helps us predict how much stretching and compression will take place. Now, why should we care about this stretching and compression? Well, it's simple. Understanding this allows us to control the final dimensions of the bent part accurately. If there's too much stretching, the part may become too thin and weak. If there's too much compression, the part may buckle or warp. So, knowing the K factor can help us avoid these issues and ensure that our bent parts are of high quality. Furthermore, the K factor is also used to calculate the bend allowance, which is the length of the neutral axis between the bend lines, or in simpler terms, the length of the metal as it bends. This is important because it helps us determine how much material we need to make a bend. And there's more. The K factor can also be used to calculate the flattened length of the material. This is the length of the material before it's bent, which is very useful when we need to cut a piece of sheet metal to a specific size before bending it. In short, the K factor is a powerful tool in the realm of metal bending. It helps us predict and control the bending process, ensuring that the final product is exactly as we need it to be. Remember, a precise K factor equals precise bends. Always take it into account during your bending process. Let's quickly recap what we've learned today. We started our journey by diving into the world of bending parameters. We discovered that these parameters are crucial for any metalworking project, with the three primary ones being the thickness of the material, the bend radius, and the bend angle. We then moved on to the concept of the neutral axis, the theoretical line in the center of a bend where the material neither compresses nor stretches. This is where the magic happens, where bending truly comes to life. Lastly, we delved into the K factor, a ratio that represents the location of the neutral axis in relation to the material thickness. This little number is a game changer, affecting the precision and consistency of bends. By understanding these concepts, you're well on your way to achieving more accurate and consistent bends. Thanks for tuning in, and happy bending.